All right, so here we go with compound inequalities. Compound inequalities are when we have two inequalities within the problem we're trying to solve. So here we go. So compound, what does it mean? It means when you have two or more things making up one system. And for compound inequalities, we consider it in one of two ways. Either it's this or that. That is, it's either this answer or it's this answer. Or we might have situations where it's this answer and it's this answer. We see two inequality statements like this or this. You'll see the or the and written in the problem. With the and, sometimes it's written in such a way that we have to infer that it is an and by the time you finish the problem, you'll discover, yes, that was an and inequality. So look for those statements. Or inequalities are referred to as disjunctions, and inequalities are conjunctions. Con meaning come together. Here's an example of a disjunction. So we have negative x plus 5 is greater than 7, or that same value of x might be in 3x minus 7 is greater than or equal to 2. To do these, we have to work each of the problems in turn. So first, let's work the one on the left. We get that x is less than less than negative 2. Now we have to switch over and do the other side. So we go through the process of solving it the way we solve any other inequality, and we come up with x is greater than or equal to 9. Then we have to graph it. So first we graph the one on the left, and because it's less than, it's an open dot. The one on the right is also, actually that should be a closed dot, and it looks like this. So a number that satisfies a disjunction must work in one inequality or the other inequality, but it will not work in both. The numbers between here will work in neither. So let's pick something from the middle. So if we have 0, x is equal to 0, and we plug it in, we discover that that's false. That's what we expected. If we put it in the other, we see that that one is also false. X equals negative 3. That will work in negative x plus 5 is greater than 7, but it will not work in 3x minus 7 is greater than or equal to 2. This is a disjunction. Now let's look at a conjunction, or the and. We have two inequalities, and we have to work each of those in turn. So we do the first one on the left to get that p is less than or equal to negative 3. We do the one on the right to discover that p is greater than negative 9. So that's an and we graph it. P less than or equal to negative 3 is here. P greater than negative 9 looks like this. So you see the two overlap. So our solution is actually only in the overlapping space. So all our answers will be greater than negative 9, but less than negative 3. Less than or equal to negative 3. If we take a number like negative 7, which should work, and we check it out, we get that indeed negative 6 is less than or equal to negative 2. If we put negative 7 in the right one, the right inequality, we get that 42 is less than 54. These are both true statements, so indeed this is a conjunction. For inequalities, the solution must work for both of them. That is, for and inequalities, conjunctions, the solutions must work for both of them. Here are some examples that you can work through and test. Got 2 pages of these, and the answers are here, should you want to go through those. So in class, we're going to go through some of these. Let me know how it goes, and let's do some compound inequalities.